Hi, in this video we'll be doing a Stokes Theorem example. We're asked to compute this using Stokes Theorem, where f is this vector field and our curve is the intersection made by the plane x plus y plus z equals 1 and the cylinder x squared plus y squared equals 9. This is orientated counterclockwise as usual. So we start off by saying what Stokes Theorem says in a nutshell kind of is that these two are equivalent. This is double integral of a curl dot ds. So we can do that. So let's parameterize the plane and the cylinder. I'm going to put it directly into polar coordinates. You can wait, but I think it's a good idea for me to do that right away. Let's do that. X, R, and theta. We get this translation into polar coordinates because we have our plane here, x plus y plus z equals 1. This can be changed to z equals 1 minus x minus y, and this is what we have here, right here. And with a cylinder, we know that the radius is 3 here because x squared plus y squared equals r squared, and so r is 3. So that is our parameterization right here. So with this parameterization, we can find the partial derivatives with respect to r and theta, and this will be our ds. So ds equals x sub r cross x sub theta. So if we do that, let's do it over here. xr equals cosine sine and minus cosine theta minus sine theta, and then x theta, x sub theta, this equals this right? Okay. So when we do the cross product of this, I'm assuming you know how to do that, and it's a bit messy. And so a lot of things cancel out here. These go away, these go away, and we kind of see this reoccurring theme of the cosine squared and sine squared, and we know those equal 1. So in the end we get r, r, r. And then with this we can do this dotted with our vector field here. So after we get our cross product here, which is also our ds, we can do our curl of f, which in another video I actually have on my channel. I show how to do or find the curl. So if we do that quick, f x squared C this will turn into we have this. We're finding curl, we do the nabla or del operator crossed with our vector field. Some people may argue there's a big difference between polar and cylindrical. I guess I don't really worry about it too much, and so we get from here down to here, and so we can set up our integral finally based off of this, the Stokes theorem. So 0 to 2 pi, 0 to 3, then this, so we can see here, we do the dot product. We see a sine squared as a cosine squared, so maybe we can get a little idea of what we're going to see. So if we do this, dot product 0 times r is 0, r squared, cosine squared, theta times r is this, dr d theta. This dr d theta should be included when we do our ds. I guess that's something to take note of. So we factor out r cubed, so these go away. So we're left with 0 to 2 pi, 0 to 3, r cubed dr d theta. So this is fairly easy. This is r to the 4th over 4, 0 to 3. This is, I believe, 81 over 4. Then you can use this. 0 to 2 pi d theta. This equals 81 pi over 2. There. I hope you learned something from this video. At least I provided an example on how to do one.